Um, yeah, so this year we have a slightly different program rhythm. Most of our sessions are only happening in one room. So if you walk into a conference room and it's pretty empty and the session should be going on, that probably means we're over in the other one. Those things are marked on the feed loop program, but if you need clarity, also feel free to ask an organizer. And then a quick note, you can see right now there is a poll open up on the screen here. We have a few people viewing the conference who are getting pesticide credits remotely. And so because of that, they just need to take a quick quiz in order to validate their pesticide credits. So those aren't for you. Apologies that they're in the way for us. So now, without much further ado, I wanted to get started. So I was going to introduce our first speaker, Dr. Lisa DeVetter, and she is going to talk to us about hydromulching for sustainable agriculture. Thanks, Lisa.
All right. Well, thanks so much, Betsy, for that nice introduction. Again, I'm Lisa DeVetter. I'm the small fruit horticulturalist at the Mount Vernon Research and Extension Center. And today I'm going to be presenting a former graduate student's project on hydromulch, or we call it the sprayable mulch, as you see here in this picture. Now, before I go any further, I want to acknowledge Brian Malpin, who is a technician in my program, and all of his wonderful contributions for helping fabricate this application system that you see here, as well as collecting the data after the departure of this student. So in this presentation, I'll go over some preliminary findings from a trial that we conducted in day neutral strawberry. I'll also define what a hydromulch is in case you're curious and aren't quite sure what this is. And then I will also forecast what we're going to be doing with future research experiments on this project. So first, what is a hydromulch? So just out of curiosity, how many people have heard of hydro seeding? You can raise your hands if you're in the audience. I see quite a number of hands. So this is really similar to hydro seeding. Hydro seeding is you're applying seed with some type of mulch in a slurry, usually for erosion control or revegetation purposes. We're practically doing the same thing minus the seeds, and we're using different formulations so we can create something that functions like a mulch. So you'll see here this formula. Our hydromulch is water plus a cellulose-based fiber. Primarily paper is what we're using and what others have used in the past, and then a tackifier, which acts as a glue, binds the material and gives it the integrity more like a mulch that we can use for horticultural purposes once it's dried down after being applied like a slurry. So you can see in these pictures here, this is application of the hydromulch in June of this year. And then this is our trial in Mount Vernon, where we're growing day neutral strawberries with hydromulch and looking at how they compare to more traditional mulch technologies. So why hydromulch? There's a lot of good mulch options out there. Why are we interested in this relatively strange method of application? Well, first, there's really few weed management tools out there, and they seem to be diminishing over time as well, particularly for specialty crop growers and for organic growers as well. Now, there are non-biodegradable mulches made from plastic or polyethylene mulch. Those are excellent. They can suppress weeds. They also provide a lot of horticultural benefits as well through modifying the soil environment, but they do have some costs with regards to the removal and to their disposal as well. And if you're interested in reducing plastic waste generation, these aren't necessarily great tools because they generate a lot of plastic waste. There's also soil biodegradable plastics. We've looked at them a lot. They're a really promising technology. There's still more information that needs to be learned about them before widespread adoption or recommendation. But if we're thinking about organic agriculture, based on their formulation, they're not allowed in organic agriculture. And then hydromulches, they can be made to be adapted in organic agriculture because the ingredients are organic approved or bio-based. They also are sprayable, which is a novel and relatively easy application method. It could work for spot application, and it also can be engineered to be multifunctional. One thing we're curious about is impregnating hydromulches with some type of biopesticide or other types of pesticide or fertilizers for additional benefits. We first just have to figure out application, formulation, and crop response. And then previous research has been very promising on them as well. And I'll highlight some of that previous research in the next slide. So here are some of the previous researchers that have worked with hydromulch. David Granatstein, who is a former Agricultural specialist, worked a lot in tree fruits. He looked at it in tree fruit production systems. He collaborated with Klein and Hyogo in tree fruit systems. He retired, no longer carried forward with the research trials, but then at North Dakota State University, our now colleague, Dr. Greta Gramig, has been working on it. And actually it was a grower who found an extension report on hydromulches. They emailed it to me and said, hey, I think we should try this in blueberry systems. And after further discussion with other organic growers, they felt this was a good technology to explore for organic blueberry as well as other specialty crops. And that led us to where we're at right now with this 4-year funded project. So the goals of this 4-year project is to first design and develop various hydromulch formulations that could be applied in specialty crop production systems. Our program really focusing on small fruits. We also want to develop and test various application technologies. It's a slurry, so it's a little bit more challenging to try to engineer a system for effective deployment. Where we focused on this past year was to really evaluate its efficacy and impact on crop yield and quality. First year, 2022, we looked at day neutral strawberry, and then our plans next year is to look at this in organic blueberry systems in Eastern Washington. When we do that, then our plans are also to look at how soil health is impacted, if this is an economical option of mulching in organic systems, and then to extend that information as well. So let's talk about the day neutral strawberry experiment that we just did. We had 2 different locations. We had one in Mount Vernon where we're based, and then we also had the experiment repeated at North Dakota State University with our colleague. It was a randomized complete block design experiment with 4 replications and 6 treatments. You'll see those treatments on the following slide. Each plot was about 15 feet long, 3 feet wide, and we applied our hydromulch formulations over preformed raised beds on top of the drip tape. And then that was applied in June of 2022, June 1st to be specific. And then we followed up and planted bare root albium plants. And the data that we collected include yield, fruit quality, mulch performance, weed suppression, soil temperature, and moisture data. So these are the treatments that we had in our experiment. We had a polyethylene mulch control that you'll see here. And then we had 5 different hydromulch formulations. One that was paper only, and then the rest were either 2 or 6% psyllium or guargum, which were our tackifier or our glue to bind this material together. Now, we chose these based on previous experiments that were done with our collaborator at Montana State University that looked at over 20 different formulations, and they found these were the best that they recommended for field deployment. Now, a little bit about the application system as well. We used a semi-trash pump to agitate the slurry that we siphoned into a 55-gallon drum, and then we used a hydroseeding nozzle that emitted our product at about 40 gallons per minute. It took us about 3 passes to get to a desirable rate. In the future, though, we plan to add additional nozzles to our application system so that we can be more efficient in our deployment of this mulch material. So let's start looking at the data. This is a preliminary look at what we've generated so far. So we looked at mulch performance or deterioration twice a month from application to crop termination. What I'm showing here are images taken on the 15th of September. So you can see we have our polyethylene control, our various hydromulch formulations, such as 2 and 6% psyllium and 2 and 6% guargum, and the material that had no tackifier. So the mulch held up pretty well throughout the experiment, which I was really surprised. I thought it would be like paper and it would deteriorate rapidly. However, it held up well. Without the tackifier, though, we did notice that in some of the plots it started to deteriorate where that drip tape was. Now let's look at weed suppression. So we measured weeds both by counting as well as measuring shoot biomass at peak vegetative production, which was August 12th of this year. And you can see these data in this figure where we're looking at dry shoot biomass on the y-axis, and then on the x-axis are our various treatments. The blue represents broadleafs or dicots, and the orange represents grasses or monocots. So you can see we had 0 weeds in our polyethylene mulch control. It did a very good job minimizing weed germination and growth, whereas our hydromulch treatments did not do a very good job, particularly for weed species like thistle and pigweed. So you can see here in this image, we have thistle and pigweed growing up through the hydromulch. Now let's look at our soil temperature data. This was very interesting. So we measured soil temperature at a 4-inch depth. And what I'm showing are two representative days early in the season, June 28th, and later in the season, September 28th. So we have temperature on our y-axis here, and then time over a 24-hour cycle on our x-axis. So what we noticed early in the season is that our polyethylene mulch treatment, which is this black line, had higher soil temperatures relative to all of our hydromulch treatments. But once that canopy developed on our strawberry plants later in the season, we saw no differences in our soil temperature. Now, one thing we were concerned about is because you're not having the soil temperature gain, the concern is that we're not going to get that benefit on crop growth because of that soil warming effect that darker color can provide. So we're thinking maybe in future trials of adding a colorant to help with soil warming. Now let's look at soil moisture. Again, this was measured at a 4-inch depth. They're set up very similarly. We have soil moisture on the y-axis, and then we have time on our x-axis, both early in the season on the 28th of June and late in the season on September 28th. Overall, soil moisture was lowest on our hydromulch treatment at 6% psyllium, greater with 6% guar gum, and intermediate for polyethylene mulch. And now the yield. This was most surprising because I thought without that soil temperature gain, we would see lower yields in our hydromulch treatment, but we really didn't observe that. We saw greater canopy development with our polyethylene mulch control, just visually, but when we look at total yield measured in yield per plant, which is on our y-axis here, and our treatments, we saw that our hydromulch formulations with 6% psyllium or 6% guar gum were greater statistically than our polyethylene mulch control, and all our other hydromulch formulations were similar. So we did see yield benefits with hydromulch or certain hydromulch formulations relative to the polyethylene mulch control, which was surprising for us. So these are our conclusions to date. Hydromulches, they did not suppress the weed species that we had in our field site relative to polyethylene mulch. So thistle, as well as pigweed, and then lamb's quarter were able to grow up through the different formulations. However, despite that, we saw that the hydromulches were able to maintain or even improve strawberry yield under the conditions of our study compared to polyethylene mulch. And we think it might be due to the soil temperature, that even though we had a warmer soil temperature earlier in the season, that it maybe was more optimal for strawberry growth and development. So this is a very early snapshot of this project. We still have more data to analyze. We have fruit quality work to continue to evaluate, but our future is to continue with data analysis and then to take this experiment into Eastern Washington and assess how they fit into organic blueberry systems in Eastern Washington and assess how they impact soil health, as well as the economics of this overall application system. So I'd like to acknowledge this project was funded from the USDA Organic Research Extension Initiative. That's why there's so much emphasis on organic systems. I'd also like to thank Charlie Gunderson with NorCal Nursery for donating our strawberry plants, as well as all of the people that you see listed here for input and assistance with helping us design our fabrication and application system, as well as data collection. So with that, I'd be happy to take any questions that you have. You also can email me, or we also have a website on this project. But I think I already see Alan Schreiber with a question.
You said the weight of the application was about 4,000 pounds per acre. How much of that was water?
That was predominantly water. I don't remember the calculation off the top of my head. So, but a large part of it was water.
All right. Good luck with this in Eastern Washington. We'll teach you what weeds are about.
Yes. I'm very curious to see. We know there's quite a bit of weed pressure out there in those systems. So thanks, Alan.
It's really interesting to me. It's like a practically new thing for me at least. But I'm just curious, what's the how to look towards the runner production with this bunch?
Okay, great. So the question from Nadia was about runner production. So we didn't measure runner production. We just went through that once or twice every week to remove runners because we're trying to minimize them with day neutral strawberry production. We will have canopy data that we measured so we can look at how vegetative growth of the plants differed or were similar across the treatments, but we haven't analyzed those data yet. Yeah.
Did you run into any emitter clogging issues? With the
Yeah.
Right.
So the question was about emitter clogging on the drip tape? Yeah, so no, we didn't see any issues specific to the mulch treatment causing any emitter clogging. Okay. I think my time is up, so unless there's a few more questions, all right, well, if you have any input, happy to take them. This again is perhaps the most interesting project I worked on, but hopefully useful down the road. Thanks.